So your logit model looks like this. Capital Li is called the logit. It is equal to beta 1 plus beta 2 xi. Your logit is a linear function of xi, where Li is actually the log of odds ratio, that is log of pi by 1 minus pi. This is called the odds ratio of in favor of y being equal to 1, yi being equal to 1. Okay, and like I said earlier in the last slide, we are now going to discuss a few properties of the logit. The first property of the logit is, since it is equal to beta 1 plus beta 2 xi, we know that the value of L can range from minus infinity to infinity. Okay, we do not use less than equal to. We know that since it is beta 1 plus beta 2 xi, my value of L can range anywhere from minus infinity to plus infinity. When the L takes on the limit value of minus infinity, my pi is actually equal to the value 0 and my probability pi is equal to 1 when Li is equal to positive infinity. You can always confirm that by putting these limiting values into the formula and evaluating the limits. So what this means is, although my logit can take any value from minus infinity to infinity, the essential condition that probability should lie between 0 and 1 is satisfied when we run this model. Li is equal to beta 1 plus beta 2 xi. So that was my first property. My second property related to the logit model is that although L is linear, in xi, my probabilities pi are not linear in xi. Remember, this was one of the shortcomings or one of the drawbacks of use of the LPM, linear probability model. There we had said that pi is equal to beta 1 plus beta 2 xi, and our problem was it's too simplistic. Probability is linearly related to the x variable or the value of the explanatory variable. So that problem is solved when you do the logit. The third point is that you can extend this example to a multivariable case. That is, you can have more than one regressors, more than one explanatory variables. How many variables and which all variables to include as the explanatory variables is ideally understood from the theory behind the phenomenon that you're studying. Okay, so always remember to choose your variables based on sound economic theory. Okay, the fourth property of the logit which you need to remember is that if L is positive, what it means is, as the value of what it implies is, as the value of the regressor increases, the odds in the favor of y equaling 1 increases. So odds in favor of my variable y being equal to 1 increases. and if the value of your logit is something negative, it implies that as the value of x increases, the odds in favor of y being equal to 1 decreases. Okay, so please remember this when it comes to drawing conclusions from the output tables. So if L is positive, it means the odds that the regressant equals 1 increases, and if L is negative, the odds that the regressant equals 1 decreases as the value of x increases. So here the value of beta 2, or the coefficient of x, is the slope which tells you how much the log of odds in favor of the regressant equal to 1 increases when the value of x increases by 1 unit. Alright, so it is not delta y by delta x, or change in y due to a unit change in x. It's change in the odds in favor of y being equal to 1. Log of odds in favor of y being equal to 1. How much does it change when x increases by 1 unit? Another point regarding this that I want to say is, like I said, here everything tells you how is the log of odds in favor of y being equal to 1. How does it change when the value of x changes? We know that the logit is ln pi by 1 minus pi. So if you want, you can always calculate from the value of li, estimated value of li, you can always calculate the value of pi and directly report it in terms of what is the probability of owning a house given a certain value of xi. Right, so you just need to do a little bit more calculations, and you can actually, if you have given the value of estimate of li, you can derive the value of pi using this formula over here. We know that li is ln pi divided by 1 minus pi. So you can always use this relation to transform your output and report it in terms of probability of owning a house rather than in terms of log of odds in favor of owning a house.